Okay, for lesson 6.6, we're doing function operations. And for those function operations, we're going to start with just the basic operations. So we're going to have two functions, f of x and g of x. We're going to add them. We're going to subtract them. We're going to multiply them. And you're going to divide them. And sometimes when we're doing these different operations, they may write these a different way at the same time. So where we have f of x plus g of x written as two separate functions, at the same time they may come back and have it so that it's written more like this. So it may be that they do f plus g of x, or that may be f minus g of x, or they may do f times g of x, and for the division it may be f divided by g of x. And the big thing with these, when you're going through these parts of it, is that with the first two, with addition and subtraction, that really all you're going to do is you're going to combine like terms. So you're going to add, subtract, anything with variables the same, you're going to add or subtract those. Anything with just constants, same thing, so you're just combining like terms. And with multiplication, most of the time on this one, it's going to be the full method, maybe a little bit of distributive property. So that's pretty much your two options that you're looking at for that one. Probably full method is going to be your big one. You'll do a little bit of distributive property just based on the problems. And with the division problem, that you're going to factor and cancel if it's possible. And this one's kind of a 50-50 because sometimes when you write down what the expressions are, they won't factor, which means they won't cancel, which means that once you write this expression, that's pretty much about it. The one kind of thing that they look at this one is that when you do the division part on the f divided by g, the one thing you have to make sure is that if they talk about excluded values, going back to the last couple of sections, the exclusions or the restrictions, you cannot have whatever your denominator is, in this case g of x, equal to 0. So that would be a restriction that you're looking at when you're going through these. So if they ask you to list your domain would be any real number, or is all real numbers. You just have to exclude any denominator equal to 0. So that's kind of one restriction that you have for this part of it. So, like the problems we've done in the past, you've got to make sure that your denominator doesn't equal 0, because that's going to cause you some problems when you go through these. And the thing on that one is, if there is nothing in the denominator, if it's all whole numbers, if there is no denominator, then you have no exclusions. So some of the problems it's going to ask you to talk about what the domain is, well, if there's nothing in the denominator, then your domain is just all real numbers. So you're always going to start off with all real numbers, and then you're going to tell me the numbers that you would exclude from the denominator equal to 0. Okay, so let's give you a couple examples here. So let's say that f of x is 2x squared plus 8, and g of x is x minus 3. So we're going to go through and find all the different things from this. So the very first thing is we're going to do f of x plus g of x. Well, we're just going to take the first function, 2x squared plus 8, and then add that to x minus 3. Now, with addition, You really don't need this one because this is almost basically like with the plus sign here that it's basically that it's 1 times everything. So with the addition part, you can just get rid of the parentheses. And now you're just going to combine like terms. So we've got the 2x squared by itself. We've got the 1x, which would be by itself. And then you have 8 minus 3, which would be a positive 5. And that would be the answer that you're looking for. And again, sometimes they give it to you like this. Sometimes they may give it to you like this. But either way you go, it's still the same thing. You're going to take the first function, add it to the second function. Okay, with the same two functions, this time we're going to do subtraction. And when you do subtraction, you have to be careful. Because it's 2x squared plus 8 minus x minus 3. And you may be saying, well, why are you putting those in parentheses? Well, the biggest thing is that when we do the subtraction, it helps a little bit with this one, because if you don't put this, sometimes you'll make a simple little mistake. The first parentheses is okay. It's 2x squared plus 8. With this minus, this is basically that it's a negative 1, and that negative 1, you're going to multiply it by both parts. So it's negative 1 times x, and it's negative 1 times negative 3. So again, first parentheses doesn't change, but that second parentheses with the minus, you're going to change this to a negative x. And if you do minus a negative 3, that's going to make it a plus 3. So that when you combine your like terms, the 2x squared is okay. You've got a positive 8 and a positive 3, that makes for a positive 11. And then the negative x is there. And we're used to seeing these in descending order. So we'll go with 2x squared minus x plus 11 for our final answer. Okay, so with subtraction, just be careful that it is minus both of these two terms, whatever terms you have back here. So you are going to have to change both of the signs of whatever the second function is that you're working with. Okay, for part C, multiplication. So we're going to do f of x times g of x. So that's 2x squared plus 8 times x minus 3. And again, with this one, it's just going to be the full method. So we're going to go back through and go through all the steps to come through the full method. So we've got 2x squared times x. That's going to be 2x to the third. 2x squared times 3, negative 6x squared. 8 times x is 8x. And 8 times negative 3 is a negative 24. And for this particular problem, the way it was set up, that's the answers, because this one's x to the third, that one's x to the second, that one's x to the first, that one's just a constant. So for this one, once you've done the full method, that's as far as you're going to go. Oh, now, and kind of backing up here, we didn't talk about the domain. That any of these three questions, whether it was part A, part B, or part C, for any of those answers, if they ask you for the domain, it would be all real numbers. And if they want it in interval notation, that would be from negative infinity to infinity. Because on all the parts back up here, when we were doing this one, no fractions in the original problem that we had, no fractions in the g of x, so no matter what we did in the original part, there were no fractions at all as we were working through this problem. So if they asked for the domain here, no fractions in the answer, it would have been all real numbers. Same thing for the B part, no fractions here, so it was all real numbers. Same thing with this one, no fractions, so the domain would be all real numbers. Now for part D, this one we would actually have some restrictions because it is a fraction. So if we plug in the f of x and the g of x, we have this. And every single time we do this, the very first thing that you want to think about is you want to factor, because technically these things are in parentheses. So before you can cancel, you have to have exactly the same thing in parentheses. For this one, you could factor out a 2 and make it x squared plus 4. But for that one, that's as far as that would go. And if somebody's saying, well, is that not two perfect square numbers? Yes, it is. But to factor this farther, that would have to be the difference of two perfect square numbers. And since it's the sum, there's nothing we can do with this one. So that would be the final answer. And for this particular problem, though, if they ask you for the domain, the answer is still all real numbers. But you have to exclude the denominator equal to 0. So for this one, we'd add 3 on both sides. So it's all real numbers except for 3. And if they want that answer in interval notation, you're starting at negative infinity. You're going up to 3. You're going to skip over the 3 and then go to infinity. So they ask you to list all the exclusions. This would be your one exclusion that you have. This would be the answer in interval notation. Yep, so there's one example we'll look at. We'll go ahead and look at another example, for example 2. So for this one, we've got 3x squared minus 11x minus 4 for the f of x, and then for g of x, we're going to do x minus 4. Okay, and for this one, we're not going to do all of them because the addition and subtraction are almost the same thing. We are going to do subtraction on this one, because that's the one I want you to be careful of. So for part A, we're going to do f of x minus g of x. We're not going to do addition for this one because you're just combining like terms. You never have to change any signs. You just put it all together. But for subtraction, we're going to do the first function, f of x, and then we're going to do minus the second function, which is g of x. And again, first function doesn't change. But the second function, but that's a negative in front, we're going to change this sign to a negative x. And if we do minus a negative, that's going to change that to a plus 4. And from there, we're combining like terms. 3x squared is okay. You've got a negative 11x, and technically that would be a negative 1x. So if you've got negative 11 minus 1, that's a negative 12x. And for this one, the negative 4 and the positive 4 would cancel each other out to make 0. So for this problem, that would be it. Now, they may not always ask for the same two functions in the same order. We could do a part B on this one, where we're going to change up the order. So part A, we were taking f of x minus g of x. We could take the same problem, and then for part B, is this time we're going to do g of x minus f of x. Same problem, just in different orders. So for that part, we're going to start with x minus 4, and then we're going to subtract 3x squared minus 11x minus 4. So we reverse the two orders here. So for this one, same thing. The first would be okay. G of x, we're not making any changes to it. This one, you're going to change all the signs back here. So change that to a negative 3x squared, change that to a positive 11x, and then change that to a plus 4. And then come back and combine your terms and see what you have. So we've got the negative 3x squared is by itself. We've got a 1x here, so we've got 1 plus 11 for 12x. Negative 4 and positive 4 would cancel each other out, so for this one, we'd have a negative 3x squared plus 12x as your final answer. And if they asked for domain on this one, there were no fractions in any of the problems that we had, so this one would be all real numbers, or if we do an interval notation, it would be from negative infinity to infinity. Okay, for C, we're going to do f of x divided by g of x. And again, f of x was 3x squared minus 11x minus 4. And that was over x minus 4. And with division, we said you want to be able to factor and cancel. So for the C part, you've got to see if you can factor. Well, the numerator is what we're going to have to factor. The denominator is okay. It's just x minus 4. So we've got to see if we can factor 3x squared minus 11x minus 4. Okay, so to factor this one, we're going to have to do the AC method. So we're going to start by multiplying 3 times negative 4, which is negative 12. And you're looking for the factors of negative 12, where the sum would equal negative 11. So we either have 1 and 12, 2 and 6, or 3 and 4, which are your only factors. And because the B term is negative, that has to be with the bigger number. And then if you divide a positive or a negative and a negative, that will get you a positive for this one. So the pair that would add up to negative 11 would have to be the 1 and the 12. Now, because we did the bottoms up on this one, we multiplied by 3 in the beginning. We've got to go back and divide by 3. For the second parentheses, that'll make it x minus 4. This one won't simplify, so we're going to do the bottoms up, pull the 3 up in front of the x. So for this particular fraction. Okay, so once you've got it factored, then we can basically go back and rewrite it. So this fraction would be 3x plus 1 on the top times x minus 4, and on the bottom you had the x minus 4. So then you can factor these two things to simplify down to 3x plus 1. Now for these, they're going to ask you for restrictions, so we're going to go back to the original problem where you had the x minus 4 in the denominator. So you have to exclude x minus 4 equal to 0, and adding 4 to both sides, you're going to exclude x equals 4. So for this one, this would be all real numbers. But you're going to exclude x equals 4. And if they're going interval notation, that'd be negative infinity to 4, and then from 4 to infinity. Okay, and then the last example we'll do for this problem with those same two functions with f of x and g of x is we're going to do multiplication just so that we can see it. So we're going to do f of x times g of x. Or again, they may have it written so it's f times g of x. So if we do f of x times g of x. Now this one's still full method, but it's a little bit longer because it's 3x squared times 11x minus 4 times x minus 4. So as we're going through these, you've got basically a couple different options. Since we've got this two part back here, then, so we're going to do distributive property. We're going to do x times this, x times this, x times this, and then -4 times all these. Okay, with x times this one, we get 3x to the third minus 11x squared minus 4x. And for these problems where you've got the extra term here, instead of just being 2 by 2, when you do the distributive property with the -4, write that under this the like terms here. So you've got -4 times 3, which would be -12x squared. So instead of writing it out on the end, just put it underneath the x squared term. -4 times -11, that's a positive 44x. So put it under the x term. And then -4 times -4 is a positive 16. If you do that, everything is lined up, and it makes combining the like terms a bit easier. So this would be 3x to the third minus 23x squared plus 40x plus 16. Okay, so there's our final answer. And again, if they ask you for domain on this one, there are no fractions. So the domain would be all real numbers. Okay, a couple more examples. Okay, for this problem, we've got f of x is 2 minus x, and then g of x is 1 over x. So for the a part, let's do f of x minus g of x. And again, we'll do that just so we can be careful with the signs. And when you do this one, you've got 2 minus x minus 1 over x. So first fraction, or first function, 2 minus x is good. With the 1 over x, it's just the minus in front, so that would be that. Now, for these kind of answers, when you're adding and subtracting, they're going to ask you to eliminate the fractions. And to do that, we're going to do like we did in the last chapter, that we're going to multiply by your least common denominator, which in this case is going to be a little bit easier because the only thing in the denominator is x. So we're going to take every single term and multiply it by x. So we've got 2 times x minus x times x minus 1 over x times x. Okay, so doing that, you've got 2x for this term. X times x is x squared. These x's will cancel and leave you with a minus 1. So you could leave the answer here. Or you could take that answer, if you put it in descending order, you also could have negative x squared plus 2x minus 1 as an option as well. Okay, and if they ask for domain, that's going to be all real numbers except for your denominator equals 0. Well, if you set the denominator, which was x up here, equal to 0, that's the only thing you had, so it would basically be that. It's all real numbers except for x equals 0. Okay, for the b part on this one, we're going to do multiplication again. So we're going to do f of x times g of x. So that's going to be 2 minus x times 1 over x. So that's 2 times 1 over x, just doing distributive property. This one, when you do the x times 1 over x, the x's will cancel. So that's 2 over x minus 1. Okay, and same thing with the last one. You're not going to have fractions in the answers, so we're going to multiply by. Okay, so again, we're going to multiply by the least common denominator, which again is still x. So we're going to take that original problem we had, multiply by x. To eliminate the fraction, so we don't have a fraction answer. And these x's will cancel, leave you with a 2. When we do the negative 1 times x, just the negative x. So you can either leave this answer, or you can have it as negative x plus 2. And the restrictions would be the same thing, since the only thing we had was this x equal to 0 for the domain. It would be all real numbers. But we're going to exclude x equals 0. And for the last one on those two functions, we're going to do f divided by g of x. So it's going to be 2 minus x over 1 over x. Okay, so for this one, the biggest thing on this one is it's a complex fraction. So we can do this one of two different ways. We can either go back and multiply everything by x, which is what we're going to do here in just a second, or you can also think about that this one is basically that it's 2 minus x divided by 1 over x. And then we can go back to keep it, change it, and flip it. So that would make that 2 minus x. And again, we'll put that in parentheses because it is on the top here. Times, when we change the division multiplication, we're going to flip this upside down and make it x over 1, which would really just be x. So that's 2 minus x times x. So multiplying both of these by x, that's 2x. That was x squared, so that's our final answer. Or again, if you want to put that in descending order, we can have that answer. Okay, and again, if you go back up here at the beginning, we still had the x equal to 0, so if they ask for a domain on this one, it's the same as the other answers, that it's all real numbers. But we're going to exclude x equals 0. And then the last thing we'll look at for today. Last thing we're looking at is composition of functions. And it looks like this. It says it's f of g of x. Or sometimes they'll do it in the reverse order and they'll do g of f of x. And what we're looking at for this part is basically we've got two things here. Now, sometimes with this one, they'll also do like a double parentheses, where you've got f parentheses, g of x. This one, sometimes they'll put g parentheses, f of x. But basically for this one is you're going to plug the inner function, g of x, into x, or into the x variable, in f of x. So we're going to take g of x, we're going to plug that in for the x variable in f of x. Better word of saying that. And for this one, we're going to do the same thing. This one we're going to plug, this time we're going to plug f of x in for the x variable in g of x. And the first time I did this one, I had a little bit of trouble with it. I finally came up with a pattern that works. So let me just show you what this looks like. That if f of x is equal to x plus 2, and g of x is equal to 4x minus 3, we're going to find, for part A, g of f of x. Again, sometimes they'll write it like this. And the way I finally figured this one out was that when I had this, whatever's closest to the x, we're going to start with that. And you're going to plug f of x into g of x. And I would actually take this and write this out, that f of x was x plus 2. So I was going to take this entire thing and plug it into g of x, which was 4x minus 3. So everywhere you had an x, you're going to take this x out and replace it with x plus 2. So it's going to be 4 times x plus 2 minus 3. So it's 4x plus 8 minus 3, which would be 4x plus 5.